All right, so I apologize about the messy pen handwriting issues. It is not me. I mean, sometimes it's me, but this has not been me the last two classes. There is an issue with when they were trying to fix it, they've calibrated the pen like 3 times, and so I apologize. Last lecture, we can get through this. We are going to finish the ANS system, and we're picking back up at ANS physiology. We finished up with our referred pain, and so we're going to move on from there. Just as a reminder, tonight is Tuesday. There is at the library another study doodad, I think 3:30 to 7. There's going to be food again. Some faculty, some tutors. I don't know if they have prizes or not, but they have food. And so help with study skills. It's not just for the science classes, math and English and other courses as well. So not a bad idea if you have time or you're going to be at the library studying anyway tonight. Thursday we will not meet. This should be our last lecture. And you guys have already done your lab practical, so you don't have to worry about lab anymore. So you're not coming to lab anymore. I believe there's just one more person left that does not see their lab practical score. So I posted where the curve would be if it had been set. Once that last person comes and sees me, they can find out what their grade is, because then I can run it through the Scantron machine. Other than that, Thursday we don't meet for lecture. Tuesday is your exam. I will post today, if I forget, somebody remind me, for the internet students to tell them to sign up for their exam. So exam 5, you sign up for it if you are a internet student and taking it at a testing center. Otherwise, you are taking it here. For exam 6, however, it is different for the internet students. Internet students, they are not having you make an appointment at the testing center. You just show up. So I advise you show up early, because it's kind of like first comes, first serve, and once a computer opens, then they will let you take the next computer. That's for internet students. That's for exam 6 during finals week. They would have the option to take it Monday or Tuesday until I think it's 2 p.m. on that day. For exam 5, it's till 1 p.m. because if you're here at 1 p.m., you can take it with the class. So your guys' final, since I won't see you on Thursday, I'll see you for exam 5. You will take exam 5 home with you. If you're an internet student, you'll have access to print yours off after the in-class students have taken it, or you can come by my office and pick up a blank copy of exam 5. Then you will have everything you need to study for exam 6. Exam 6 will be 10 questions from each of the first 5 exams, word for word, identical, other than, because there's 3 versions, it might be flipped around on the answer order. But you have all the questions already. You just have to memorize them. It's not changing the answers or anything else. I will not put one on that was questionable. So if we had an issue where I had a mistake on one of the exams, those questions that had the mistake would not show up. So I'm not putting anything that was questionable on there that somebody had an issue with, okay? And anything else about the final? So you guys show up for the final, you take your exam. Some people are done in like 20 minutes or less because it's pretty much pure memorization at that point. You turn it in, you're done. Yes?
The final's Tuesday at 2, correct?
The final will be Tuesday at 2 p.m. It is different because we have to abide by the final schedule. So normally we would have been 1 o'clock here, but it's 2 p.m. on that Tuesday of finals week in room 106. Everybody has to sign up if they're going to take that exam. You will see that after exam 5, it'll say, once you guys have all taken exam 5, the scoring will be posted on how you figure out where you were in the curve, because the curve is not set until after exam 5. So when you go to type in your ID number to see your grade on exam 5, it'll also give you all the information about what your grade is and how to determine what you need to get on exam 6. And then from there you can decide, if you don't sign up for exam 6, whether you're an in-class student or an internet student, then I do not print off those exams. So you need to let me know if you're taking that exam or not. Then I print off the right amount of copies, and then we're ready to go. Yes?
Are we signing up online or in class?
It'll be online. So it'll be on the AMP website. It'll say sign up for exam 6. So you guys will see. So even though we don't meet for lecture again, keep an eye on the postings on the AMP website, and it'll give you the directions on signing up. And you guys can always email me if you have questions, of course, okay? Anything else? All right, let's do this thing. So ANS physiology, neurotransmitters and receptors. So with neurotransmitters, if we think about just in general, trying to classify things like sympathetic versus parasympathetic. So sympathetic, we know that we have adrenaline, which is epinephrine and norepinephrine. Parasympathetic, we know what tells our skeletal muscles what to move. What's the neurotransmitter important for that? ACH or acetylcholine, right? So, so that's something to keep in mind as you're trying to place this new terminology that's going on. So looking at the neurotransmitters, between the preganglionic neuron and the postganglionic neuron, they're all going to be acetylcholine. But let's look at the difference in how we set this up. So acetylcholine is released by all here we go, draw, there. Come on, pen. Don't fail me now. Preganglionic. Oh my gosh, stupid pen. All right, all preganglionic and parasympathetic. This is what happened to Sherry. All right, so pen may not work. Follow along. All preganglionic and the parasympathetic postganglionic axons. This is ridiculous. Come on. I'm just trying to get it out of the way so you guys can see. I'm sorry, what were you saying? It's definitely worse. Yeah, it is worse. I apologize, guys. All right, so. Yeah, it has to apparently do with that calibration thing, that it's just getting worse and worse. So, all right, so all preganglionic and only the parasympathetic postganglionic axons have ACH being released. These are called cholinergic. So an easy way to remember cholinergic, acetylcholine, cholinergic. That'll help you guys remember ACH with cholinergic, okay? And then we're going to learn in a minute that we also can have, I'll come to it so I don't confuse you. Norepinephrine is released by the sympathetic postganglionic axons, okay? And so the norepinephrine and epinephrine together is adrenaline. So one way to remember adrenaline, adrenal, adrenergic, adrenaline has the same base at the beginning or prefix. Let's see if this works. No. Okay, there we go. Adrenaline, adrenergic, think adrenaline or norepinephrine, epinephrine, okay? So that's why it says releases norepinephrine. So what it means by ACH is released or adrenergic fibers or cholinergic fibers, they're talking about what, if you were looking at a pre and a post area, it would be the pre is releasing ACH or norepinephrine. If it's releasing ACH, it's cholinergic. If it's releasing norepinephrine or epinephrine, it's adrenergic. That's all it's saying. It's saying that those neuron fibers are producing, remember in the synaptic knob, and it was producing it inside and then it would release it out? That's what it's talking about, okay? So what else did I tell you? So the receptors are the other side of your equation, right? This would either be the postganglionic neuron or it might be your effector that we're talking about here. So the receptors, so it says the effect of a neurotransmitter, NT, depends on the postsynaptic receptor. So again, that's either the postganglion, the second neuron, has the receptor on it, or the organ or the effector that you're talking about has these receptors on it. So when we talked about skeletal muscle, ACH was released. You had to have an ACH receptor on the muscle to recognize it, right? That's the same thing that we're talking about. So you guys already know the basics of this. Now we're just adding in more names. So cholinergic receptors. It says there are two types that can bind acetylcholine. Okay, so the two types that can bind acetylcholine, that means that these receptors were named for drugs that bind to or mimic the effect of acetylcholine. So they're still all cholinergic, but if acetylcholine can bind to it, and in this case it says A or B, nicotinic or muscarinic. So nicotinic means that ACH could bind to it, or nicotine. That's how you guys know what nicotinic means. It's talking about nicotine. Muscarinic actually came from a mushroom toxin or poison, so that's why it's muscarinic. So muscarinic means ACH could bind to it, or muscarine could bind to it, is what it's essentially saying. So let's see. So, and they were named because of these drugs, essentially. So receptors were named for the drug that binds to and mimics the effect of ACH. So let's see if I can write at all. Nope. Receptors, yeah, can be used to create drugs to activate these. So I'm sorry, guys. So cholinergic receptors can be used to create drugs and activate them or block them. They are named for the drugs that they ended up using that they found, hey, look, nicotine worked on this acetylcholine receptor. So that's why they called it a nicotinic receptor. And then with muscarine, now the difference is if it's a muscarinic receptor, even though ACH binds to it, do you think nicotine can bind to it? No. But ACH can bind to it, muscarine can bind to it. And same thing for nicotinic receptors. Nicotine can bind to it, acetylcholine can bind to it, but muscarine will not bind to it. It won't activate it. Does that make sense? So they're both cholinergic, ACH works on it, and it also means that the nicotine or the muscarine, when it is attaching to the receptor, it acts just like acetylcholine bound to it. It has the same response, okay? Let's see, what else do we want to say? So nicotinic is nicotine or acetylcholine can bind to it. It's always stimulatory, okay? For muscarinic, this is the mushroom poison or muscarine or ACH can bind to it. And it says on muscarine, all parasympathetic target organs, okay, so it can be inhibitory or stimulatory. It just depends on the target organ. So for example, if we said ACH, right, because that's a cholinergic neurotransmitter, and if we were talking about the heart, what do you think would happen if acetylcholine comes into contact with a muscarinic or cholinergic receptor on the heart? What do you think ACH would do to it? Increase or decrease heart activity?
Decrease.
Yes, it would slow down the heart, it would decrease it. What about if we were talking about the GI tract, gastrointestinal or digestive tract? What do you think ACH would do there? Would it stimulate it or inhibit it? It would stimulate it. So for the heart, it inhibited it. For the GI tract, it stimulated it, right? Because what are we talking about with ACH? Are we talking about sympathetic or parasympathetic effects? Parasympathetic effects. So that's in charge of rest digest, okay? So if it's rest digest, digest is your key word there, and you had ACH, parasympathetic, is stimulating, it means you just had a meal and you should be digesting it, so it would increase the activity. So think through what it sounds like it should be doing and see if that makes sense to you when you're applying the neurotransmitter to that area. So for the heart, when you think about the heart, the parasympathetic is typically telling your heart how fast it should beat, but it actually tells it to beat slower. So it has a certain set limit, and we go into a lot of detail about this in 228. It has a set limit of beats per minute that it should do, and as long as your parasympathetic is in charge, it actually tells the heart to slow down to what is considered resting beats per minute for us, okay? But remember, sympathetic can say, whoa, we have to be in charge right now, we're going to dominate because we have to survive right this second. So it would make sense that parasympathetic keeps it slow at a resting beats per minute, but if sympathetic has to kick in, what would sympathetic do to the heart? Speed it up. We need blood flow, and we need it now, and we need oxygen to those muscles, and we need to get out of here or be ready to fight. Okay, so just think through what should happen, and that'll help you guys determine what makes sense. Let's see, what else do I want to tell you? So we said ACH was released. We did that. We did cholinergic fibers, adrenaline, cholinergic. Okay, so under nicotinic skeletal muscles, that makes sense. All right, let's erase this because it's just in the way. Maybe it'll erase it. Wow. We're really going to screw it up now, aren't we? Oh, shoot. Undo. No. Abort. All right, so there's no abort button. Where's the Eddie key? Right? I am a font of information. It just shifted it to the left. Let's see if we can shift it back over. Right? Let's all dance down. All right. There we go. Okay. This is my work. Okay.
And the screen go up so you can write on the whiteboard?
It won't matter though for the other people, and I'm not tall enough to make it go up, and I can't lower that part down, so I'm really not tall enough at all.
Any ladders?
Yeah, shoot the ladders. All right, so follow along, and then all right, so we are on nicotinic. So nicotinic is found on all skeletal muscles, which is somatic, right? We already knew that. We know that ACH gets released at the neuromuscular junction. All of that makes sense. You guys already knew that information. It's all postganglionic dendrites. And the interesting one is also the adrenal gland. Okay. Then on muscarinic, I already talked about the heart and the GI tract. So that makes sense to us. And then this picture has a couple things that, so if we look on the first column that says parasympathetic pathway, okay, which is on the far left-hand side for you guys. That one is good. The second one over, though, under the sympathetic pathway, so the first one under sympathetic, cross this one out. You don't need to worry about this guy.
That whole column?
That whole column, you're going to cross that one out. So I'll use my mouse. This one cross out, internet students. We don't want that one. All right. The second one's okay. Now on the third one for sympathetic pathway, or the last one there, at the bottom where it says muscarinic receptors, you're going to cross that out and put nicotinic receptors. It was a mistake. In your lecture text, it is correct, but on this picture, it is incorrect. So where it, on the last one at the bottom where it said muscarinic receptor above the adrenal medulla cell, make that a nicotinic receptor. Okay. So going back and talking about this. So parasympathetic, the first column, you can put P/S to remind you, parasympathetic. The next three where it says sympathetic, you can just write SYM for sympathetic to remind yourself that, or a big S. And if you notice, all of them, even though we're not talking about the first one under sympathetic, all of them have acetylcholine being released. Notice that? Okay? So check, check, check. Acetylcholine. So those were all cholinergic fibers, right? Because it's acetylcholine. Okay? Then, on the parasympathetic, the ganglionic neuron and cell body is a nicotinic receptor, okay, which makes sense because ACH or nicotine could then bind there, correct? Also, we skipped that second one. Then this third one is also a nicotinic receptor. And then we said this guy should be a nicotinic receptor down here on the last one, okay? Now, I would have loved to have drawn an extra picture for you to try to simplify this one, but I don't think the lines will work for you very well. But if you're looking at old lectures, you could check out Peter Zayo's old lecture on the full chapter lectures. You can go over this. It doesn't have this picture on there, but he does a nice job of drawing a very simplified parasympathetic doodad. I don't know if I can, the internet students won't know what I'm drawing here, of course, but I'm short. See? All right, so for example, if we had the parasympathetic side versus sympathetic, you have your ganglion coming from your, and you have your preganglionic fiber, and you have your preganglionic fiber, right? And then it's going to have a nicotinic receptor, okay, for the next cell body. So we know ACH is being released here, ACH is being released here to talk to the next neuron, okay? Then he's going to go to his effector on parasympathetic, And these will be, he'll have like muscarinic receptors on him. So I'll put muscarinic, this is nicotinic, this is nicotinic, okay? And then for sympathetic, what do we know that it releases at the end? Is it gonna release acetylcholine to its effector? If it's sympathetic, no, what will it release? Epinephrine and norepinephrine. So make sure that you don't just put an E when you're trying to say, either put EPI for yourself or norepinephrine / like NE/E, so you don't mix up E for epinephrine with E for effector. But this would be releasing norepi and epi, okay? And this would be acetylcholine or muscarine or. So it depends on what your target organ is, right? So nicotinic, you know, is going to be your skeletal muscle. Nicotinic is going to be your postganglionic dendrites of sympathetic and parasympathetic. That's just talking about this part here, okay? And then the adrenal gland. Don't forget adrenal gland. He's the weirdo, right? And then for muscarinic, that's going to be all of your parasympathetic target organs. So that's what it said up here under muscarinic. It said all parasympathetic target organs. That's why I put the little dots on there with the effector for muscarinic, because that's all parasympathetic target organs are muscarinic. That's, pretend that's an M. Muscarinic. Yeah, you just thought my handwriting on the board was wrong and bad. Now it's bad everywhere. I can't hide behind my lie anymore. All right, so let's see. What else do we want to talk about? So those are the extra ones that you had to know about as far as the, under cholinergic receptors, you had nicotinic and muscarinic. Under adrenergic fibers or receptors, you have two types that bind epinephrine or norepinephrine. You either have alpha or you have beta. And under alpha, you have alpha 1 and alpha 2, and under beta, you have beta 1, 2, and 3. And again, I don't think the pen is going to work, but it's the Greek letter alpha. Looks kind of like a sideways fishy without the close of the tail. You guys know it, right? Let's see if it'll work. Almost, it's missing the top of its tail. I don't think it's going to do it. All right, so you have alpha 1 or alpha 2. And beta is the Greek letter beta. It's the capital looking B, but it has a longer arm on it. So yeah, that really looks great. So I'll draw it on here. Maybe blue will be better. Maybe you guys can see. So alpha 1 or alpha 2 receptors, or you have beta 1, beta 2, beta 3. Okay. So let's see what else. So adrenergic is the organs can either have alpha or beta, or they could have both. So they could have alpha receptors only, beta receptors only, or both alpha and beta receptors on the organ. Okay. There we go. Now you can kind of see both. Now I got to make sure I don't bonk my head into it. Okay. So let's see. So alpha, there's not much to write on alpha. They are usually stimulatory. So alpha is usually stimulatory. And there's just the two subclasses, alpha 1 and alpha 2. And that's all you need to know about alpha. It's not that exciting. As far as beta, beta is also usually, the general category is usually, all right, yeah. Now you can't see that anymore. Let's put it on the mouse so at least I can, no, yeah, this is great. All right, gotta love technology. There, at least you can see the pointer sort of. Okay, so beta is usually stimulatory, the general category of beta. But there's one exception, is beta 2. Okay, so beta 2 is the exception, it's inhibitory. So let's talk about beta 1 first. So beta 1 stimulates cardiac muscle, so heart muscle, and blood vessel. So if it's stimulating the blood vessel, do you think it's constricting, vasoconstriction, or do you think it's dilating, vasodilation? Think it's dilating?
Stimulation, constricting.
It's stimulating. It's going to be blood vessel vasoconstriction. Vasoconstriction. Okay.
Because if you're stimulating the muscle, you're going to be.
Maybe. Let's see. All right, so beta 1, stimulatory, cardiac, muscle, and BV constriction. There we go. Let's try this. All right, for beta 2, it's inhibitory. An example would be the lungs. So for lungs, it would relax the smooth muscle of the airways, which I know you guys are thinking, wait, what do you mean by that? So if you think about it, if you need to get more oxygen to places, if you were to constrict and let the smooth muscle contract, it would close down or open up your airway. Close it down, which is not what you want to happen. Okay, so that's why this is the weird one. Remember, beta 2 is the weird one. So with lungs, it relaxes smooth muscle of the airways and causes the blood vessels to relax and dilate. So just think fight or flight, what should happen? That's what beta 2 is doing. So we don't want to constrict our airways. So beta 2 receptors on our lungs, we want them to open up the airways. And then for beta 3 is stimulatory. And in this case, it's for lipolysis, or if you look at the word lipolysis, lipo means what to you guys? I think liposuction, lipo, fat, yes, adipose. So lysis means to break up. So it's breaking up fat so that you can actually use this for energy. So I'm going to tie this up in just a second so it makes sense. So it's stimulates lipolysis and blood vessel vasoconstriction, just like beta 1 was, correct? So when we're talking about where it says effects of drugs, try to target specific receptor subclasses to control an organ without causing side effects. So for example, our body typically, let's say, if everything is working normally, is going to work in a way that makes sense when you need fight or flight versus rest digest, okay? Now, when we figured out how to stimulate certain receptors, and we could create what would be called, say, a global drug, which is meaning not specific. So if we create a drug that stimulates all the beta receptors, is that a good idea, or are some of those going to not make sense? Correct. So your body's going to be more specific for when it needs something done. But when we introduce the idea of a drug to the system, it may not be very specific. And then they realize, wow, that caused other side effects that we didn't want to happen. We need a more specific drug for only these receptors. So we can create a drug that only affects beta 1, beta 3 receptors, or only affects a beta 2 receptor. And that might make more sense. So for example, the term beta blockers. So I'm writing out beta because I can't do the Greek letter right now and it would take me too long to insert it. So beta blockers, okay. So for example, for blood pressure, what do we want to do when people have high blood pressure? We might want to give them something called a beta blocker to decrease their blood pressure, okay. So if the prescriptions or the medications are best if they're more specific for a beta 1 and beta 3, then it would affect the blood vessels, right? So that might be okay. So if we block the beta receptor, so beta 1 and 2, if it's stimulated, is going to vasoconstrict. If we block that from happening, what might happen to our blood vessels then?
Relax.
It would relax or not constrict, not be allowed to constrict. So it would keep it more open and relaxed. That would be good for somebody with maybe high blood pressure, right? Okay, so then blood vessel, so that means that the blood vessels would relax because if we stimulated them, they would contract. We're saying don't stimulate. We're blocking you from stimulating it. Okay, but it also stimulates the heart. So what did we say that beta one does. If it's stimulating cardiac muscle, what would it do if we, so it's stimulating it, would cause that to go up. So if we say, no, we want you to slow down, okay, so it increases the heart rate. So a beta blocker would do two things. It would help decrease your heart rate, and it would help block the vasoconstriction. So it decrease heart rate and cause then vasodilation, right? So not constricting, okay? So a beta blocker does that. Now, if we used it for, say, somebody that has tachycardia, meaning cardia, increased heart rate, okay, and increased vasoconstriction, that might be a good thing to use a beta blocker for that person. Now, beta blockers, would that be an agonist or an antagonist? Antagonist to beta receptors, right? They're against the beta receptors, so it would be an antagonist to beta, I can type, beta receptors, okay? I'll scroll this up so you guys can see that a little better. And what if we have somebody, though, that has asthma? So if a person had tachycardia and asthma, let's say, right? And we gave them a drug like a beta blocker. Is this a good idea for our asthmatic? It'd be good for the tachycardia part, but not for their asthma side of it, right? So because asthma, their airways are hyperreactive, this is a global or a general beta blocker that we gave them. And there's a couple of drugs, but I'm not a medical doctor. You guys might hear them, propranolol, Inderal, things like that. That would block all of the beta receptors, and that would actually make them more susceptible to their asthma attack, because that would affect their beta 2, which would not allow them to relax their smooth muscle of the airway, because it didn't block that. I mean, it blocked that, so it's causing that problem, right? So asthma, they will have, a lot of times you guys have heard people with asthma have like an inhaler, right? Inhaler. I didn't mean to do it backwards. There we go. And another slash. And then, let's see. So they will have what's called a beta 2 agonist is in that medication for their inhaler. So a beta 2 agonist, because it's a helper, right? Not an against it type of thing. And it's specific for beta 2. So it's not affecting beta 1 and beta 3. So when we know what receptor works on certain organs, it helps us, one, to create drugs that can be more specific, and it makes sense to have a drug that's more specific than doing one drug that might be great for a lot of people, but then can cause, because not everybody knows they have asthma, right? So you give them this global medication, they don't know they have asthma, you didn't know they had it, you give them that, now they have an asthma attack. Now you got to give another medication to counteract that part of it, right? Because the people that know they have asthma, then you would obviously not give them the global one. But for those that you didn't know, you may inadvertently cause a problem because it was kind of under the radar. They didn't really realize when they couldn't breathe well what the problem was. So that's all we talk about with the effects of the drugs. So interactions of the autonomic division. So the term dual innervation means organs receive innervation from both branches. Okay, so that makes sense, dual, too. So one branch is dominant over the other. Good thing I can type somewhat fast. Antagonist interaction is if the activity of one branch increases, the other would decrease. So that makes sense, right? So if you guys want to think about, too, like the whole piano player thing again, right? So with dual innervation, sympathetic and parasympathetic, remember we said they're both on. It's just one is louder than the other, one is more dominant over the other, but they're both on at the same time, okay? And then antagonistic interactions, it means one is always playing louder than the other. That's all that means, okay? So when we say that the branch increases over the other, we're talking about the output or the tone, right, that you end up seeing with it. So then if we look at number 3, I think our numbers got cut off on the side, sorry, sympathetic and parasympathetic tone. So sympathetic tone and parasympathetic tone. I'm going to jump down to parasympathetic tone first, right here. So parasympathetic tone, it says constant partial stimulation, even at rest. This makes sense because this is the whole rest digest thing with parasympathetic, right? So the current heart rate is in rest digest mode. And if we look at where it says heart and smooth muscle of most organs, so that means it's under constant parasympathetic stimulation. Okay, and it limiting organ activity or function to what's called normal levels. Okay, so this is where I was saying the heartbeat, which you guys will learn, like I said, in a lot of detail in 228, is told to beat at 100 beats per minute constantly. However, because your parasympathetic is working properly, it tells it to slow down, to be at resting levels, and that is between 60 to 70 beats per minute. Okay, so if everything's working right, even though your body is programmed for the heart to be at 100, because parasympathetic is always on and you're at resting, it's telling it normal should be at 60 to 70. So it's telling it to slow down all the time. Stay at 60 to 70, stay at 60 to 70. That's what it's telling it to do, okay? If, and that means parasympathetic is dominant. But now you have somewhere to go also if sympathetic had to kick in all of a sudden. So if the fire alarm went off all of a sudden, then your heart rate could go up really fast, closer to the 100, not a problem, right? Because sympathetic now would become dominant over parasympathetic because it's emergency time, it's survival time, it's I'm in charge right now. Parasympathetic is still on, but he's in the background. He's playing quieter. Sympathetic is now in charge because your life might be in danger now, okay? For sympathetic, okay, down here, it can override in case of an emergency. So that's what I said about the fire alarm. So that's that part. Now let's go back up to, that was all under parasympathetic tone. Now let's go back up to sympathetic tone, which says constant partial stimulation even at rest. Okay, so what that means is with vasomotor tone, all right, so that means vasomotor tone will increase or decrease the sympathetic stimulation to constrict or dilate blood vessels. So we have increase or decrease sympathetic tone, or sympathetic tone, same thing, stimulation, to constrict or dilate. BV is blood vessels, okay? So vasomotor tone has everything to do with blood vessel diameter. So I'll put that sympathetic tone, BV diameter, okay? So blood vessel diameter. What this means is if I have a normal shaped, so let's say this is my normal shaped blood vessel, okay? And if I were to dilate it, it would be much larger so that the diameter, meaning more blood can flow through it. And if I were to constrict it, it would be tinier, right? And I'm going to draw some lines on top of those three circles to indicate what would be normal sympathetic tone, right? So let's say with the middle-sized circle, I might have, say, 4 lines going to it. That is indicating how much neurotransmitter I might drip in that area to tell me what kind of tone I should have, so this being normal. So if I'm super constricted, what do you think would happen to the number of lines I would draw on top stimulating this area? If I'm constricting it, it's going to be tons of lines there, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, something like that, right? I'm dripping tons of neurotransmitter on it to get it to constrict, okay? And if I'm on this side with my enlarged diameter, how many lines do you think I might have there? If I had 4 for normal, maybe I have 1 or 2, so I'll draw 2 lines on that one. So that's what we're talking about on that aspect of it. So few lines, sympathetic output, not very much. Vasodilation, larger diameter. Normal would be the sympathetic output or tone is, you know, say whatever the normal amount is that we would be releasing. And then the output for a vasoconstricted blood vessel would be tons of lines because we're doing tons of stimulation to it to tell it to constrict. Now, parasympathetic has no impact on this. This is only sympathetic, so this is kind of unique here. I'm kind of getting into the unique sympathetic role, so let me lower this down again. Okay, so let me scroll up a little bit. So unique sympathetic roles, it's kind of at the bottom here where it says blood vessel diameter, vasomotor tone is sympathetic only. Okay, so parasympathetic has no impact and does not innervate or affect the blood vessels, except in one area that you learn in 228, but for this semester right now, just sympathetic only. This is the only thing that's important there, okay? So, let's see, what else do I want to tell you? I think that was everything on that. Majority of the time, are we parasympathetic or sympathetic dominant? Parasympathetic, okay? So, so that's why we say sympathetic can override in case of an emergency, right? This makes sense. Sympathetic is the only one that has to do with the blood pressure, blood vessel diameter. So unique sympathetic roles. This makes sense to you guys if you think about it. We have thermoregulation in response to heat. Okay, so these all mean there is not dual innervation. Like we said, dual before. These are just sympathetic only. Okay, so thermoregulation in response to heat. So when we get hot, this is a way we can cool ourselves down. We can do this by, I don't know why all my numbers had disappeared. I'm so sorry that happened, guys. I can't shift it over. So with decreased sympathetic, this goes over, and increased sympathetic went over like that in your notes, right? So decreased sympathetic output to the skin and the blood vessels would dilate. So this is like a radiator cooling off the car, okay? And we can increase our sympathetic output to, for example, the sweat glands, because more sweat to an area is what's called conductive heat, cooling. So, so both of those are only thermoregulation. It's only sympathetic only. Parasympathetic has nothing to do with that. Your erector pili muscles. So when you guys were looking at skin and skin with hair, remember that little tiny muscle, erector pili muscle, and he makes your hair stand up? Exactly. That's sympathetic only, okay? Metabolic effects. So this is due to sympathetic stimulation of the adrenal gland, okay? So, oh, erector pili muscles, we can put goosebumps because that's what happens when your hair goes up, right? Goosebumps, okay. Metabolic effect due to sympathetic stimulation of the adrenal gland. So this has to do with your fight or flight adrenaline release, okay? So norepinephrine and epinephrine release essentially. Increased metabolic rate of body cells. So these guys all go kind of over a little. So increased metabolic rate of the body cells. Does it make sense that if you have to increase the metabolic rate of the body, that each individual cell is going to ramp up what it needs to do as well? So that's what it's saying. And if you increase the rate at what the cell has to make and do function-wise, you need more food and fuel for it. So that's where glucose levels increase, because you need food for that. At some point, you're going to run out of the glucose levels. So remember we talked about electron transport chain and all that, or is that next semester? We didn't talk about that. That's in 228. You guys learn about your energy cycles and stuff. 228, sorry. So when you run out of glucose, now what's the next fuel you need to use? Fat. So that's why it says mobilizes fat for fuel, because now we can do that lipolysis thing. We can break our fat down for additional fuel, because you're going to run out of that glucose until you can refuel again. And then it says increase mental alertness by stimulating the RAS. So this just means we're turning up the volume. We need to be more alert and ready to go. We're talking about sympathetic here, so that makes sense, right? And then we already talked about blood vessel diameter, only sympathetic, okay? So that was cool. Localized versus a diffuse effect. So localized means one small area. Diffuse means think whole body essentially, okay? So when you have parasympathetic and it says single preganglionic neuron, synapses only to a few postganglionic neurons. So that's important, right? So does few mean local or diffuse to you? It means local. So let's write localized. Okay. All release acetylcholine, we know this, which is quickly destroyed in the synaptic cleft. You guys remember that? Who destroyed the ACH? Acetylcholinesterase. So ACH ACE. That little ACE. Acetylcholinesterase, right? That destroyed it. So does that mean local or does that mean diffuse to you? It's still local, right? Because if it's short-lived is what I guess I should say. That would be better than saying local or diffuse. If you are constantly have an enzyme there to break it down right away, it's not going to keep stimulating. You got to keep making more ACH in order to keep stimulating it because you have all this ACH ACE, acetylcholinesterase, breaking it down constantly in that synaptic cleft. Okay, so it would be a short-lived effect. Does that make sense? Short-lived? Okay. If we look at sympathetic, it says single preganglionic neuron has branching axons which synapse with many postganglionic neurons, each to a different location. Is that localized or do you think that means diffuse?
Diffuse.
That would be diffuse. Okay. And it says release of norepinephrine, which is not broken down quickly because it is endocytosed back up into the presynaptic endings. So it's not broken down quickly because it takes time to break it down and to bring it back into your cell and then reform it again so you can spit it back out. So do you think that this is a long-term effect or a short-term effect? So this would be a long-term effect. Anything that's getting into your bloodstream also is going to be a long-term effect, and it's going to be diffuse because it's going throughout the whole body if it's in the bloodstream also, right? So let me make sure I put things in there right. So release of ACH, I put ACH ACE. Let's put also short-lived and localized effects. Okay, and then for sympathetic, we had diffuse and release of norepinephrine. Let's add a little bit to that. So we know that it is a widespread effect. Widespread effects. And we also know it's long-lived. We also know that the adrenal medulla is also stimulated to release epinephrine and norepinephrine, which prolongs sympathetic effects also because it's getting into the bloodstream. All over the body is getting affected. And so this is also why if you, after, let's say, whatever that fight or flight moment was, maybe it's a car accident, maybe it's the alarm that went off, it totally freaked you out for a minute there, whatever it is, and sometimes you're still a little jittery afterwards, you're shaking a little bit, and it takes a little while for that to calm down. It didn't just shut off the minute the problem was over, right? It takes a minute to relax again and come back to your rest, digest, Zen mode, right? So that's another way to think. Sympathetic is longer lived, widespread effect, because it makes sense that if you have to get out of a situation or fight or flight, whatever it is, that your whole body has to be prepared to do it, and it's going to take a little while to calm it down again. Okay. Control of autonomic function. So let's see. So where does it start? So if we look at brainstem and spinal cord control, it says many organs are controlled by the brainstem. And so things like your heart rate, vasomotor tone, that's talking about your blood pressure, okay? Respiratory and GI or gastrointestinal control centers. And have to do with the medulla oblongata. So all these control centers have to do with they're located in the medulla oblongata. So remember we said before, it can affect your heart rate, it can affect your vasomotor tone, it can affect your respiratory, right? So that's what we were talking about. Medulla oblongata is pretty important in all of this. And if we look at autonomic reflexes, okay, so these are, oops, nope, stop, don't do it. I don't know. I can't type. All right, let's just add it in there anyway, make it work, right? Okay, so this is spinal cord, and it has the same components as the somatic reflex. How many were in somatic? 5, right? So same as somatic reflex, except it has 2, and that's not how you spell neuron, 2 neuron motor chains, so that would put it at what? 6. So it's similar to somatic, but it has 6. So it has a pre and post ganglionic neuron. And let's see, so that's autonomic reflex. Let's talk about, where do I have that on here? So medulla oblongata does all of that. If it's talking about brainstem and spinal cord control, what area are we talking about? So up here when we said, yeah, somebody said it, cranial sacral. What's cranial sacral in? Parasympathetic, right? Parasympathetic is cranial sacral. Many organs controlled by the brainstem, cranial sacral, okay? Let's see, and what else do I want to tell you? If we're talking about autonomic, it's probably talking about like thoracolumbar, right? So if we look at our example here of the bladder, so in the bladder we have stretch receptors. So I can't draw my picture here right now, but on the organ itself there are stretch receptors, right? And it's going to stimulate and tell these guys what's going on. So if it fills, you are filling up your bladder with urine, it's going to stretch the bladder. Okay, it's going to stretch out, spread out. So that is afferent or efferent information going to the spinal cord and then the brain. Afferent, it's sensory, right? So afferent to the spinal cord, it synapses in the dorsal horn, right? The interneuron there is going to synapse to a preganglionic neuron. So motor, efferent pathway, and the arrows here, so it sent the information in, it went through our dorsal root ganglion, it went to the dorsal horn here, then it synapsed with an interneuron, the interneuron synapsed with a preganglionic neuron that then sent the information down to, okay, they're saying postganglionic, so maybe they didn't show the pre and then the post on this picture, I'm thinking. And so if we follow that down to, if I tell you it's a pelvic splanchnic nerve, because it didn't tell you that, do you know if it's a para or prevertebral ganglion then, from last time's lecture? So if I tell you if it's a splanchnic nerve, it would be shout it out, be confident. Splanchnic nerve meant it went to the pre, right? Post to pre is splanchnic. Blah, 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 blah. Say it 5 times fast, right? Okay, so it gives you a clue that it's parasympathetic if I'm saying the pelvic splanchnic also. It's telling you parasympathetic, right? So yes, because it had to go pre to post is pelvic splanchnic.
Okay.
Yeah. Right? So I think here it says pelvic splanchnic nerve there. Yeah. So it told you that. If you see pelvic splanchnic, you know it has to be parasympathetic, right? Because that had to do with P for pelvic and S for splanchnic. I told you associate it with, because a splanchnic nerve by itself, if we just said splanchnic, what does that tell you? Sympathetic. Okay. So let's see, this is voluntary muscle that you can control as skeletal muscle. So skeletal muscle must be associated with the sphincters of allowing you to release the bladder, right? Because you guys end up being potty trained at some point. So you control it. Yeah. So if you control it, it's got to be skeletal. because you can't control the other one. So another thing to note here at the postganglionic axon, what's another name for that guy here? We are at our target organ. What's another name I could say for this area of my postganglionic axon?
Muscarinic receptors.
Yes, I could say muscarinic receptors. And what about the ganglion itself? What could I call it? A terminal ganglion, which only has to do with parasympathetic also, right? See how you guys can make all these connections? So what I suggest is that when you guys go back through the notes and you see something that, like, create a couple different things. Do somatic versus autonomic. Do a thing on sympathetic versus parasympathetic. And start listing all the things that you know are similar or slightly different between the two things. And that will help you guys see the big picture in the end, because we touched on a lot of these little things separately in the different areas, and now it's about bringing it all together for the big picture. So let's see what else. So terminal ganglion, that means the cell bodies of the postganglionic neuron are down there, right? Let's look at hypothalamic control. So this is a number 2 next to it. It says hypothalamus is the main integration and command center for the autonomic control. So this is affected by the limbic system. And what was your limbic system good for? Emotions. And also your thalamus, which is the sensory info, which means input, right? Afferent information. Let's see, cortical control, this is a number 3, has the smallest amount of input. So talking about meditation, this is, learning how to tune out external stimuli and focus on relaxing to decrease your sympathetic activity or tone. So I'll put some of that on. So this is learning how to tune out external stimuli, which means that you can increase your parasympathetic activity. And what you're trying to do is you're meditating in order to decrease your sympathetic activity, right? So you can control it a little bit. And the more you practice and focus on it, maybe the better you get at being able to cause that to calm down. So for example, like white coat syndrome, you go into the doctor's office, you associate the white doctor's coat or nurse's coat even with getting an injection, and that's an ouch, and you don't want that. And so immediately your heart rate and blood pressure are increasing, and so you might hang out in the room for a while and breathe in and slow down your breathing and slow down your thought processes to calm yourself so that your blood pressure slowly goes down and your heart rate goes down. And so you could do that through practice. Also, biofeedback. With biofeedback, this is learning how to decrease your sympathetic activity by using like an external monitor or source that helps tell you when you are within a realm of being too high or too low. So this machine is hooked up to you, essentially like electrodes, and you might hear a tone or a noise that's like, and you can bring it down, and that means you're in the right Zen mode and you're doing good and you're more parasympathetic at the time, and all of a sudden you think about something and it goes, kind of like, what do you call it? Polygraph test, right? It can measure like you're sweating more. It can measure that your heart rate is up. And all it does is you think of one thing and you're, I stole something once when I was 2, I don't know, right? So this is learning how to decrease sympathetic activity with the use of and rehearsing an external monitoring equipment okay? So if you think about it, for example, if you have somebody, let's say like a homeostatic imbalance of, they have hypertension, let's say, right? So some cases of an elevated blood pressure could be due to an overactive sympathetic stimulation due to maybe high stress levels. Who is not under a lot of stress because of work, because of school, because of exams, because of family stuff, things that are going on? we can have high blood pressure due to the stress of that situation. And sometimes it's not that you're overreacting, but your body is continuing to be in a stressed level in sympathetic tone instead of going back into letting parasympathetic take over and put you back at rest digest mode. So it's like you're always up and stressed, right? Okay, so you could give somebody a medication for that, but does that help what the reason was behind it? No. So you're telling the body to calm down, but you're not addressing the real reason why they have it, right? So if you address the stress level itself and you worked with them, whether it's meditation, biofeedback, whatever it is, getting some stress off their plate so that way they don't have to take a medication to calm it down, their body should self-regulate and go back into their rest, digest, parasympathetic dominance, where it should be, as opposed to constantly being hyper in sympathetic mode. Does that make sense? That's all we're talking about there. So that is it. Yay, exam 5, 227 is done. Just so you guys know, for 228, if you are looking ahead for when you come back in the fall, your first lab, we would be working on some of the special senses and looking at the eyeball. So the first day you come to lab, you will be dissecting an eyeball. And I believe we've had some people that have brought in a lot of fresh specimens. So we have not only the cow eyeball that is a preserved specimen, but you can compare it to a fresh specimen as well. And so if you're trying to review something over the summer, right before we come back, you will have access to the AMP website all break long, but you're not going to have access to the Connect assignments, because if we start that and allow you guys to get in them early, if there's anybody that didn't purchase or get into Connect, they would not be able to, their 2-week grace period at the beginning of the semester starts when the first person registers for the class. So it throws everything off if we allow you guys to start working on those assignments early, just for that reasoning. But what you can work on is you could look at, technically, because you have access in your 227 account, you can still get into the, what's that called? The Phil's book, because you'll have Phil's, but you'll also have a new assignment called Learn Smart Labs, that you'll be able to get into that if you're just trying to look ahead. But your assignments won't get recorded in the proper place until we can allow you to sign up, which will be like the first day of the first week of fall semester. But you could look at the eyeball. You can start looking at the parts of it. Don't stress about it now. Focus on exam 5, review for exam 6. But for those of you that are thinking ahead, because I won't get a chance to talk to you again verbally, you can look at the eyeball for 228's first day of lab. That's all we're doing. But we will walk you guys through registering properly in the right course for 228 when you guys come back in the fall, so don't stress about that either. And exam 5 is all the way to the end of what we just talked about. Study, ask questions, email me, stop by my office, ask me questions to clarify things, come up after class. Any other questions about the information today? And I'm very, very sorry again that the pen didn't work and was super squirrely. Yes?
Is exam 5 going to be somewhere online that we can get it to study for exam 6?
So for exam 5, you will get it on, when you leave class, for the in-class students, you will get your exam when you leave. For those that are internet students, once exam 5 is taken by the in-class students, it'll be made available where the internet students can print it off, or they can come to me after 2:15 p.m. on that Tuesday and I can give them a blank. So either way. And then you'll have all of your questions then once you've done exam 5 to study for exam 6. And then exam 6 will be in here, or if they're internet, they'll follow the instructions for internet students. But it'll be in here at 2 p.m. for exam 6 because of the final schedule. So exam 5 is still 1 p.m. in here, room 106. Exam 6 will be on that finals week, Tuesday at 2 p.m. is when it starts. Any other questions? Yes?
Can we sign up ahead of time for exam 6, or does it have to be after 5?
For me or for the testing center?
Just for exam 6.
I think as soon as exam 5 is done and the grades are set, you will have a specific spot there to click on to sign up for exam 6.
Okay.
It'll prompt you. So you guys will enter your grades because everybody wants to know what they got in the exam. So they'll get in there and then it'll say, click here for registering for exam 6. All that tells me is how many people are physically going to come in and take it. So I only print off that number of copies. And you just bring the ticket. You don't have to bring the ticket in with you. You can take a picture with your phone if you don't want to carry the piece of paper. So you can have it up on your phone that it shows that you registered for it, because Sherry gets that you registered it on her end, and she'll tell me how many copies to print off. You guys will come in, you'll just show me quickly that you have your ticket, whether it's on your phone or the piece of paper if you print it off. Does not need to be in color or anything else. And then I pass out the exam, you guys take it, and bada boom, you're done. Yes. Oh, yep, let's do clicker questions. All right, internet students, bye.